Okay, so our very last one was us trying to figure out which one of these situations, this is the most compressed image in the world, and I'm sorry about that, but which one of these situations has the largest rotational kinetic energy? And this argument is kind of quick. So what we're saying is we can kind of think about each one's rotational inertia, because what we're saying is our kinetic rotational energy is equal to 1/2 I omega squared. And I said in the video that the omega is going to be the same. We're going to pretend that they're all spinning with the same angular velocity. So really what it boils down to is our rotational inertia. And sure, we have all these equations for rotational inertia, but what we saw when we did that tightrope lab was that the rotational inertia really boils down to how much mass do you have and how far away is that mass from your rotational axis. So in this very first case, when we're doing what we call the spider roll, this just kind of flip, in this case, a lot of his mass was just kind of right near this center of rotation. So we didn't have that much mass very far away. So I'm going to rule this one out and say, well, we don't have a lot of mass far away. Sure, we got the same amount of mass, but most of it is concentrated right where we're rotating. So I'm going to say no for that one. I'm going to say that this one probably doesn't have the largest I value. In fact, I'll say it has the smallest I value. With this one, when we're looking at this helix, I think is what it was called. Um, when we're looking at this one, a lot of his mass is really right near this central axis. So we really still, again, we have a lot of our mass rotating right along this central axis. So I'm going to say with this one too, most of our mass is really close to this axis. So yes, we got mass, we have the R, but a lot of it is really, really close to where he's rotating. So he's pretty much rotating right along that axis, which means it'll be fairly easy to get him to rotate. It was kind of like when we had that lab set up. If you had your mass really close, it was easier. These are my masses versus when they're far away. And then for this final one, in this case, kind of we have a central axis. This is really the only one where while he's rotating, his body isn't really on this center point. It's not really on this axis of rotation. I don't know why I'm doing this on the pen. It's fine. So he's kind of rotating along if this is where he's rotating about. So this is kind of the bulk of his mass is far away. So he has more mass, most of his mass is far away from this axis of rotation, which means I think that this one has the largest I value, which means that I think that one will have the largest rotational kinetic energy. And that is my theory on that one.